Chapter 20 from the Farm Management textbook by Kent Olson talks about investment analysis and uncertainty. As you recall from the syllabus, we're not discussing time value money or ag finance topics this semester. We're doing some accounting concepts, but not actual any time value of money or those type financial formulas. However, in this chapter, you are responsible for knowing the 4 different exhibits, and we'll talk a bit about those because I think they're kind of interesting. If you think of the fall of 2018, we had 2 hurricanes go through the southern part of the United States, causing billions of dollars of damage. If you've been reading the Wall Street Journal or the New York Times, they've had a number of articles talking about what happened to the tree industry. So in the South, in Alabama, the Florida Panhandle, parts of Georgia, farmers planted lots of poplar trees, hybrid poplars, and other type of conifers in the mid to late 1990s, thinking that they were that was a long-term investment, and at some point they would be able to take those trees, cut them down and harvest them for wood or for paper products. Literally speaking, the hurricane knocked over thousands and thousands of acres of these trees, and they're not good anymore for what they were planted for. And so if you think about the investment analysis on this, it's sort of like we talked about our perennial crops. You grow something, you're not going to get a return until one point in the future when you harvest that tree, or in the case of orchard crops, every year once a tree becomes bearing. But in the long run, you plant a tree with the intention of harvesting it, a lot of things can happen. In this case, one of them was hurricanes that came through and hurt these farmers. There is no farm bill for farmers that grow trees, and so they're trying to figure out how to help these farmers who have lost everything that had trees on their land. So as we think about this, the 4 example boxes in this chapter, the assets are just beyond a typical year. So we're not looking at annual crops. We're not looking at livestock. We're not looking at a cow-calf cycle, which might be 21 months in length. So the first example from this chapter talks about cowonomics. And if we look around the world, what you find is that oftentimes in economic development, many societies, many cultures use dairy cows because it's a very good way of generating income. The cow milks every single day. The cow has to eat feed, which is produced locally. The milk is used locally. The animal could be used as a draft animal for horsepower if need be. So the animal only has value when it's alive. When the milk cow is dead, it no longer has value. So you've got to make sure and take care of that animal, and the cost of not doing so is very significant because the animal could die. So this is different than a typical stock or yield, which has dividend payments and a possible increase in the value of the investment. A dairy cow is a much different type looking investment. Let's think about investing in woody energy crops. So if you think about the investment return from a forest, follows a similar process. You plant a tree, and at some point you harvest that tree. It's a common issue in planting trees which have a long-term date when they reach maturity. So Purdue University some time ago discovered a way to produce a plantation of black walnuts from 90 years down to 45 years. So they have the time it took to grow a black walnut tree. And black walnut wood is very highly prized in furniture. It's very highly prized in tables and chairs and so forth, bookcases. And so what the Agricultural Experiment Station economists were saying was, look, if you plant an acre of black walnut shrub trees when you're 22 years of age, prune it, take care of it, put a fence around it, and when you turn 65, it will be worth $1 million. And they talked about this almost like an IRA account. It's a walnut tree IRA account, is I guess how I would call that. And a common formula then was, what is the upfront dollar investment I've got to have to plant this black walnut shrub, and what rate of return is needed annually to get that? And so this black walnut tree now is not the typical tall growing black walnut tree we see. It's a little more shrubby, so it's going to have a little more knots in it because there's more trees. It won't grow as tall, but it's going to grow faster. And they've got a couple different websites here where you can look at these, figure out and determine how that might grow, and other ways of looking at high-value trees here in the United States. It's kind of fun to look at these, and if a guy had the foresight when he was young and the labor, you might think about doing something like this, putting a half acre or an acre of trees like this that could be harvested for furniture later in your life. So I've done these as an exam question, a quiz question in past classes. And so you think about these, you think about the faster growing trees. How might you do this? What are two variables that you need to know to determine whether or not the statement is true? The statement is, a young farmer could plant an acre of walnut trees with a tall fence to keep deer away, and when he retired, this acre of timber was worth $1 million. So what you would need is, what is the upfront cost of buying the tree or the shrub? And what is the annual return? How fast does it grow? And what's that going to be worth when you go to harvest it at some point in the future? So what is the time horizon on this? As we think about, so that's one way. So number one is just planting a tree and harvesting in the future. Perennial crops, almonds, apples, apricots, cherries, grapes, hazelnuts, peaches, etc. These are all planted with an annual crop coming off of them. So one key decision is, how dense do you make these? There's a trade-off, an inverse, if you will. If you plant the trees too close to each other, they don't bear as much fruit. If you plant them too wide from each other, you'll get more fruit, but you're also wasting valuable space and water. So what is the appropriate length of density to plant trees to give the maximum yield and the maximum profitability? And there's a whole bunch of variables. People look at the angle of sun coming down. So where are you in the latitude, if you will, the east-west latitude in relationship to the sun? What type of elevation do you have? What type of shade do you have? Where's the water? Do you have to run the water uphill, or can it be run around flat ground? There's a whole bunch of things that go into planting an orchard crop, a nut crop, if you will, or a tree crop. And so you also want to look at its root pattern. So all of these things are very useful when you plant these, and there's a lot of science that goes into these. And the other part about this, they vary in life, but you're planting at 40 years, often a minimum time to get a bearing crop. So you're making a huge investment for which you're not going to get anything in the first 3 years. And then after 3 years, you'll start getting a crop off the tree, but then it takes a while for it to really become a full bearing orchard fruit or tree nut crop to get the right amount of investment. The California Canning Peach Association collects a lot of information on the California peach crop. The reason is because they bargain on behalf of California producers for the price of peaches. And so they need to know what supply and demand is going to be for peaches. Now, California is a great place for producing canning peaches because the canning peach requires a harder outside shell and epidermis, because that peach will be canned or frozen. That's different than a cling peach. That's different than a peach that's going to be used for fresh purposes. And so these type of peach varieties are much different. But if you look in 2018, a large number of their peach trees are in the 6 to 15 year age length. And they've got a sizable amount, 2,000 acres, that are non-bearing but will be bearing fruit by the year 2020 or so. So they've got a relatively young set of peach crops here with 25 or 30 years still left to bear fruit. So if you think about, here it is, the canning peach trees measured over time. And so we're looking at the number of trees, and look what's happened here. We've gone through a high in the early 2000s of 30,000 acres of trees down to something almost half that in the last 3 years. So what's going on in that time period? Well, we're going to look at some data, but part of it's demand and part of it's supply with regard to substitute products that farmers can plant on those acres. So here I've got, they started in 2010, was the first year I could find the pull-out acres. So how many orchards are being pulled out and either replanted or planted into something else? And so if you look, what happened was a whole bunch of orchards were planted in the early 2000s, which we saw in the, right here, 6 to 10 years and 11 to 15 years. So that's where those acres are. They were planted a lot in the early 2000s. And if you look what's happened in the last 5 to 8 years, we're pulling out more peach trees than we're planting. And so if you think about that, that's got implications for supply and demand. So what we've seen is farmers pulling out more acres, and we see that decline here in that previous slide in the peach trees. Part of this is a yielding part, so we're seeing yields go up. So yields are going up on these new trees, so we're getting slightly higher yields. And so the big decision for if I'm a California peach farmer, and I'm going to put uncertainty now into my planting density. The timing of when you pull out your trees and plant is something much different than a farmer with annual crops. Peach trees and planted almonds or walnuts have at a higher price, a higher return per acre than canning peaches have. So nut prices are very high and much more profitable. Cooperatives such as Blue Diamond, which was the world's largest almond grower, they told their members what total consumption might be and where supply was, and then encouraged farmers to plant more almonds, or almonds as they call them in California. Canning peach trees decreased because you can plant almonds or nut crops on the same acres you plant canning peaches. And finally, we were left with 2 remaining canners in California, and they said, look, if we want to keep our canning factories open, we've got to stop the pullouts and create a high price for several years, and we have to give growers longer contracts to encourage them to plant more peach trees with better varieties to stop that change, that downturn, if you will, in the pullouts. So, how do we think about price uncertainty? First, the first farmer who plants almonds and pulls out peaches has the most potential for profits. The profit stream is longest for that farmer. I think we can understand that. Their nuts crops will bear nuts quicker than farmers who waited. Trees require 3 to 5 years to become bearing. There's a huge fixed cost the first couple of years. And the farmers who did this in 2005, 2006, 2007, they're reaping the benefits now 10 years later. It's difficult to model the issue of the peach price in the new contract because that contract didn't exist in 2005. All farmers saw what was going on with the existing peach price. So if you think about the supply curve for California canning peaches, which we used earlier in the semester, we've got an almost elastic supply curve. That slope is almost a perfectly elastic line. However, in 2015 and 2016, the price went up and the yield went up as well. So we had these outliers that said, high yields and high prices. That normally is not the case when you look at typical supply and demand. So we had 3 recent outliers where higher price was paid and we had higher yields. Growers like that. Let's turn our attention from peaches to grapes. So let's think about price uncertainty with the Thompson seedless grape variety. This is one of the most unique grape varieties in the world. It's very well known in the world of grapes. You can use this as a wine grape. For volume, you wouldn't use it for flavor, but for volume, this would be like the Holstein cow of wine grapes. Or I can sell it in dried form as a raisin grape. So it could be yellow Thompson grapes or sultanas. You often see those in the grocery store. Or I can use it directly as an ingredient in processed products. I could try to identify someone who wants to buy this as an ingredient and sell it. So the Thompson seedless grape grower has a decision to make at harvest. Do I sell my grapes to a winery? Do I sell to Sun-Maid Growers, which is a cooperative which many California raisin grape growers belong to? Or should I find another raisin broker around Fresno or Sacramento? Or do I try to sell this directly to an ingredient user? That market is very small, and once that market is full, there is no one else will buy ingredients. So it's kind of hit and miss with the ingredient buyers. All 3 of these markets have huge fixed assets, and they need as much volume as they can get up to a certain point. But wineries only need enough grapes to mix with grape varieties. So their supply curve is almost vertical. Ingredient buyers only need so much to produce as well. Their supply curve is almost vertical. Sun-Maid can store these raisins for up to 2 years. But they typically have to find a supply agreement 12 months in advance. They use 6 or 9 or 12-month contracts to sell grapes. How does price discovery occur then? So suppose it's September or October. A grower is saying, I've got Thompson seedless grapes. I've got 3 potential markets. I can sell to the ingredient market. I can sell to the Sun-Maid Growers for raisins. Or I can sell to a winery and look at the price of grapes for that. So Sun-Maid is the only value-added user of those grapes. So if you think about this, ingredients and wine grapes are basically low price market for average grapes. where Sunmade will try to attract grapes because they've got raisin products and they're trying to create a value added for it. So they may have a higher price just to pull grapes away from wineries and ingredients who need product, but only a certain amount. And so the price discovery process for wine grapes and for ingredient users, that's a cash price September, October. The raisin grape price is I will pay a price to a grower in September, and then over the next 12 months, as the full value of that crop becomes known, I will give producers advance payments on the value of that crop used for raisin and other type products, and I will give the grower that. So the grower's got to wait 12 months to find the full value for Thompson seedless grapes used by Sunmade, or they can get a cash price at harvest in September, October from the winery or from the ingredient buyer. So what should I know from today? Annual crops have got much different risk issues than perennial crops. Perennial crops have time horizon issues, bearing issues, and much more uncertainty. Density issues matter, large asset values in trees, and when you have hurricanes coming across the United States, you can literally lose all of your retirement income that you had proposed by putting your trees and your land into trees, and there really is no insurance for something like that.